Imagine you're standing in the freezing wind, wearing a thick, expensive winter coat, but you are still shivering. Now imagine solid metal rods stitched through that fluffy insulation, running from freezing air directly to your skin. Cold travels down the rods, bypassing insulation entirely and pulling body heat out. This is called a thermal bridge. While wood is much better at holding back the cold than metal, it's still a poor insulator compared to the fluffy material filling your walls. Heat travels through a solid wooden stud about 3 times faster than it does through insulation, making every stud a potential bridge for heat to escape. Standard construction places a vertical wooden board, or stud, every 16 inches along the wall. That creates dozens of wooden bridges that leak your expensive indoor heat directly to the cold outside air. By using wood more efficiently, you create more physical space for the materials that actually keep the house warm. The modern solution to this problem is a technique called advanced framing. Instead of placing studs every 16 inches, we space them out to 24 inches. This diagram shows the difference side by side. Pushing those studs to 24 inches uses 30% less wood, which expands that empty space between boards by 30%. That extra volume is exactly what we want. We can pack it full of dense insulation, significantly cutting down on leaky thermal bridges. Now, a lot of people hear less wood and immediately worry that a 24-inch frame is weak or that the builder is trying to save money on materials. This wireframe explains the engineering behind the fix. To keep the house perfectly strong, builders simply stack the roof and the second-story floor right over top of those 24-inch studs. The weight travels straight down an unbroken path to the foundation. When you align the skeleton strategically like this, you get a house that is completely structurally sound while easily outperforming standard homes in energy efficiency. The long walls aren't the only places where heat escapes. We also have to look closely at the tricky parts of the skeleton, the framing around the windows, and the exterior corners of the house. Above every door and window is a supporting beam called a header. Standard builders use solid blocks of wood for this, which creates a massive thermal bridge right above the glass. The fix here is an insulated header. We replace the solid center of that wood block with rigid foam, stopping the cold spot in its tracks. Then we have the corners. This diagram shows a top-down view of standard framing, where builders cram 3 pieces of wood into every corner. It forms a hollow, closed-off pocket. When the insulators come in to do their job, they are physically blocked from reaching that pocket. That leaves an empty, freezing void right where the exterior of the house is taking the brunt of the winter wind. The modern fix is called a 2-stud corner, or California corner. By removing that unnecessary third piece of wood, the cavity opens up entirely, and insulation can flow smoothly to the outside edge. Every unnecessary piece of wood we pull out of a corner or a window frame is one less cold draft sneaking into your living room. Once the skeleton is up, it needs a skin. Standard builders usually wrap the house in a cheap manufactured board called OSB. The problem with OSB is how it reacts to a wet environment. If it gets exposed to moisture during the build, it acts like a sponge, swelling up and degrading quickly. A non-negotiable upgrade for durability is real plywood sheathing. Plywood handles rain and snow far better, giving you a rigid, reliable base. To make sure that skin actually keeps the wind out, every single seam between those plywood sheets has to be sealed tightly with heavy-duty tapes designed to stay stuck for 50 years, even in freezing temperatures. Finally, we move down to the floor. Squeaks often start in a new house because builders use nails, which can loosen and pull out over time. The overbuilt solution fastens the subfloor with screws instead of nails, locking every board in place with a continuous line of high-performance adhesive. Combining industrial adhesives, structural plywood, and heavy-duty tape results in a floor system that resists squeaking and a shell that stays draft-proof. The quality of a house skeleton comes down to the strategic placement of the lumber, rather than the total volume of wood used. If you are interviewing builders, you can use these exact details to find out if they actually know how to build a high-performance home. First, ask them if they plan to use advanced framing with 24-inch centers to maximize your insulation space. Second, ask if they will guarantee the use of 2-stud corners and insulated window headers to eliminate those hidden cold pockets. And finally, ask for a framing moisture log. This requires them to test the wood with a moisture meter to ensure they aren't trapping water in the floor before it gets glued down. Asking these specific structural questions gives you the technical oversight needed to make sure your house is built correctly from the inside out. If you found this guide to building a better home helpful, please subscribe to the channel and hit the like button below.